after, flying helicopters and, that type of thing. And I don't know, maybe I can teach you how to fix vibration problems. Are you with me? Okay. All right. We're going to go through a couple of case histories that I've kind of worked on over my career. And I think case histories are a good learning tool. You kind of see the approach, and it gives you kind of like we came, we saw, we conquered, and that type of thing. So we're going to be doing a number of case histories this morning that I just titled How to Fix Vibration Problems. And generally, we're looking for something, not to put a Band-Aid on it, but to do root cause failure analysis type of fix. All right, fix the problem so hopefully it won't occur again. All right, and this is an example of having continuous monitoring and some of the benefits that you can have from, walk-arounds are great. I made my living for 30 plus years by doing walk-around, route-based type of thing, but there are times when continuous monitoring is certainly worthwhile. This is a large air compressor that had an online system. It's a two-stage process air compressor. It's a bull gear driving pinion, so you have a big bull gear and you have little pinions for first, second, third, fourth stage. Multi-stage. Put a new control system on it, and that new control system had a feature that would stop the machine from being able to surge. If it got to a surge condition is you're operating it in a pressure and flow area where the machine is not designed to run, and it can cause some fairly violent vibration. It actually, what happens is it's compressing, the air is going through, and you're trying to compress the air so much and there's no place for it to go that it relieves itself by coming back through. So you actually get a flow reversal through the wheels. All right, so it goes whoosh, whoosh, and you can hear it sometimes when you're into and if you let it go too long, that air doesn't go through the cooler, so it just gets warmer and warmer and warmer and warmer. The machines grow, clearances are taken up, and then you end up destroying a machine. So they put an anti-surge on that says if it started to detect surge, it would automatically pop open a relief valve, let the flow continue on through the machine, decreasing the discharge pressure with a pop-off valve. They also put a Bentley Nevada 3300 series or 3300 series monitor, vibration monitor on it. All right, that was set up for alarm and trip. And then piggybacking onto that was a CSI 4500 system, which took the outputs from the Bentley system and did recordings of them, where the Bentley system is just, it's a blind, it's a meter, it says vibration is going up, trip. This one recorded frequency spectrum, time waveform, trends, all of that as part of it. So it's piggybacked onto the Bentley probes. All right, events. On Saturday, the Bentley Nevada system alarmed. They have a low alarm and a high alarm. And it hit the alarm, and then it went up and it hit the trip. All right, the CSI monitor alarmed also. All right, the operator said, well, it's Saturday. I don't want to call anybody, so he just restarted the machine. All right, he started it up, didn't review data, nothing like that. Not a good practice. If you have these protection systems and you have an event and you have a trip, somebody should be in there looking at it. Otherwise, collected all this data and it doesn't do anything for you. All right, here's a plot of the CSI system that shows that they were running along. They had a high, apparently had an event back here too. They had an alarm, came back over here, went up and tripped. All right, and came down. You look at the frequency spectrum, there's a lot of very low frequency stuff in here that would be symptomatic of a surge condition in a compressor like this. And we said, well, looks like it had surge. Can't happen. Never, can't do it. We have an anti-surge system on here, Again, we hear that a lot. No, that's impossible. All right. Well, the surge system worked, but we wanted to test it. So we were out there testing it, and the process engineer, again, he didn't, no, my system works. So we were testing the controls offline by forcing it, to simulate a surge. And a mechanic noticed that the control valve linkage was moving, but the valve wasn't moving. All right, and the linkage was loose. And so the system did what it was supposed to do. It says, oh, move this, but the valve never moved. And so they were surging. It was possible to have it happen. The anti-surge, everything worked the way it should have been here, except the operator really should have not started that machine again. Fortunately, it was on a trip, so there was no damage done to the machine. It wasn't left in surge for any period of time. But part of this is when you're adding vibration controls and all that stuff in, who's responsible to answer alarms? Operators don't understand vibration. Vibration is just another thing that sets the alarm off, and I got to go clear the alarm. They have to understand, what do they do? What's step A, B, and C? Get it? The first alarm, second alarm, what do I do? Who do I call? Who's on duty? That all has to be part of having this system. Otherwise, you're going to put this instrumentation in and it's going to do nothing for you. Okay? That's it.